Good day guys, welcome to another tutorial on FIS 309. My name is Olasindifit, and in this tutorial we're going to be treating pond construction 2. We are going to be covering the volume of clay soil to form a dike and volume of excavation. So let's get right in. Yeah, before we get started, I would like to apologize for the noise. If you're hearing a noise, background noise, actually the gen. Uh, I apologize for that. And yeah, so we're going to be treating volume of clay soil from a dike. We all remember what a dike is from the previous tutorial. If you have not seen it, please go back to the previous tutorial pond construction 1 and check it out so you understand what we're about to do here. So the volume, to know the amount of soil to form a dike, is actually very simple. You need to know the area of the dike first, and we've treated it in the previous video. So if you have not seen it, please go back there. If the let's take for example the area, the cross section area to what we treated in the previous video. Let's take for example the cross section area of a dike is 8 meters, and the dike, the area, surface area of the excavated pond is 20 meters by 40 meters. So that means in order to get the volume of soil to form the dike, yeah, it is 8 meters times the perimeter. And what's the perimeter? Since this is a rectangular block, the perimeter of a rectangle, that's from mensuration, what we did in elementary mathematics. The perimeter of a rectangle equals to 2 length plus breadth. So that means 220 plus 40, either way is anyhow 60, 120. So this will be times 120. Then that becomes this should be, sorry, this should be meter square, then times 120, and 960 meter cube is the answer, is the volume of soil that would form the dike. So that's that. Now let's go to the next one, which is the volume of excavation. We need to also know the volume of soil that will be excavated from the ground to form the pond. Okay, now so the volume of excavation, that's we're trying to know, let's assume this is the ground level. We're trying to know the volume that we are going to excavate here, like dig out. The volume of this portion, the volume of this portion. We want to know the volume that we are going to dig out to form to form the excavated parts of the pond, which actually this one is the formula for finding this. The volume of excavation equals to A plus 4B plus C all over 6 multiplied by D. Now this formula, we're going to understand it very soon. What A is actually the surface area of the topmost surface area of the dike. Like if this is the ground level, then the surface area will be this point A to A, then the mid level is this point B to B, and the base going is this point C to C. So I believe we know already now, this is the base, then this is the mid level, then this is the topmost surface. Now we need to know, in order for us to get the volume to be excavated, we need to know the area. Remember that this thing I'm drawing out is actually, this is a 2-dimension. If we're looking at it in 3-dimensional angle, then it looks something like this. It looks something like this in 3-dimensional point of view. It looks something like this, where we have the dike going, this is the, I believe we are seeing this. So it's going deep inside. So this place now is the A. This is the A, that is the topmost surface. Then this is the B, which is the mid-level surface, like area. Like we're going to know this is the length, this is the breadth. We're going to know the mid-level to length, breadth, and we're going to know this is the base. This one underneath here is the base, length and breadth. I believe we see what I've drawn illustrated here. Okay, so having known that, let's now know how to get A and B and C, the area. So once we know the surface area, we can then put everything here. Yes, and this D is actually the depth of excavation. So now, how do we get the volume of excavation? That's the question. Okay, firstly, you'd have been given the base. Yeah, you'd have been given the base area. Usually, the base area, like I said, usually is always given in question. So let's take, for example, the base area is 20 by 40, or any area given usually is the base. So that means this place is 20 by 40. That's meter square. And you now be left to calculate the area at this A and the area at B and A. You'll be asked to calculate those. Now, how do you calculate it? You're going to use the idea of the dry slope ratio to the construction height, which is, remember dry slope, wet slope. The one inside this place is the wet slope, the one outside here is the dry slope. And usually it will be given in ratio form. So let's take, for example, the wet slope here. The wet slope here is 2:1 to the construction height. Following the idea of mathematics, if I draw broken lines to the top here like this, and I draw broken lines to the top here like this, we can also assume as well that this place is 20 by 40 meters square, isn't it? This one also is 20 by 40 meters square, isn't it? So that means this little area here like this little area here like this is what is left for us to know, so that we can know the area at B and area at A. Then we can now use the formula to calculate the volume of excavation, isn't it? So then we are now left to getting these places. We are left to getting these places. Okay, now how do we get it? Like I said, we are using the idea of slope or wet slope to the construction height. Now, the meaning of this slope 2:1 means if the construction height is 1, like if this construction height now, or in this case is water depth, since we are not talking of construction height in this case, sorry, in this case it is depth of excavation. So if the depth of excavation here is 1, that means this place here is 2. That's what this 2:1 means. So it means, if just like the way we had it in dike, that this place will be 2 times the construction height, isn't it? Construction height. This one will be the wet slope times construction height. Wet slope times construction height. This will be dry slope times construction height, remember. So that means if construction height is 1, this place will be times the ratio. So what am I saying in essence? It means if this whole thing here like this is 1, it means what you have here like this will be 2. So if the ratio is 3:1, it means if everything here is 1, what you have here will be 3. And like that and so on. So I hope we understand, we get that idea. So now, if this place is 1, that means this is 2. That means if this place is x, it means this place will be 2 times x. Isn't it? Yeah. So we can then say this place, let's take the construction height to be x, the depth of excavation to be x. So it means this place is 2x. Likewise here too, let's take this place, the water depth to be x, the depth of excavation to be x. It means this place is 2x. Now, since this one is halfway, that's at least we have solved for A. Let's go to B. Now, since this place is halfway, that means this place will be half of x, isn't it? If this place is half of x, that means this place will be 2 times what you have, isn't it? So that will be 2 times this. That means it's x, and this place 2. If this place is halfway through, that's halfway through times 2, which is still x. So that means this place is x. So now, drawing it very well, this is A, this is C, which is the base, this is B, and this is A. So it means, if we already said this one is this, let's assume it is this, and we already said since we've drawn the broken line up, this one is also this, then this place is also this. It's now left for us to know these little spaces here, and we've already gotten that from what we did. That means if this construction height is x, so that means what we have here will be x times the slope, the ratio of the slope, which is in our case here. In our case here, we said it should be 2, so 2x, and this place also 2x. And since if this is x, like we said, that means halfway here will be half of it. So that means if this is x divided by 2, that means this should be 2 times whatever you have here, which is x if you calculate it. So that means this is also x. So from this, we can then say that the area at A will be what? 20. Let's first take the breadth. 20 plus 2x plus another 2x. Please let's take note of this. 2x plus another 2x. Now, and then for the breadth will be 40 plus 2x plus another 2x. And the same way goes for B. B will be 20 plus x plus another x, and then the other one will be 40 plus x plus another x. And C is already what we know, and 40, 20 and 40. So now, having known this, we can then say that the area. Now it's not left for us to, based on if the question might go in any form. Question might come in any form. Let's take this question. The bottom dimension of the pond is 20 by 40 meter square. The dike, the slope, the ratio of slope is 2:1 for both sides, dry and wet slope. Now the depth of excavation is 0.80 meters. Calculate the volume of soil to be excavated. So what we already know what to do here is just to draw out, and then so you might not even need to draw out since you already know the formula. You might not need to draw out, but let's just draw it out. This is, we already know this is 20 by 40 meters square. Then if you trace it up like this is also 20 by 40 meters square, 20 by 40 meters square. And we already know that everything here like this is 0.80 meters. This one too is 0.80 meters. If, let's just see, now it's an arbitrary, is a question, just an assumed question. So that means if this place is 0.08 meters, what would this place be? It will be 2 times 0.0, which will be 1.6 meter. Then this one will be 1.6 meter, isn't it? And if this place is halfway of 0.8, that means this place will be, if this place is halfway of 0. That means it's 0.40 meters. So if this place is 0.4, that means this will be 2 times it, since our slope, like we said, is 2:1. So that will be, this one will be 0.8 meters, this one will be 0.8 meters in this place. So we already know what to do. We can then say the length will be 40 plus 1.6 plus 1.6. Breadth will be 20 plus 1.6 plus 1.6. That's for A. B will be, length will be 40 plus 0.8 plus 0.8. Then breadth will be 40 plus 20 plus 0.8 plus 0.8. And so basically that's just it. So, all you just need to do now is find the answer. This one should be 43.2 meters. This one will be 23.2 meters. This one will be 41.6 meters. This one will be 21.6 meters. Then this one will still be 40, and this one will still be 20 meters. So now all we now have to do is find the area. Area is length times breadth, isn't it? Area of A is the length times the breadth of A. Area of B is length times breadth of B. Area of C is length times breadth of C. So once you've done all those, then inputting it into the volume of excavation shouldn't be a problem. That will be A plus 4B plus C all over 6 multiplied by D, which D is the depth of excavation. So area that you get in A, put it in A. Area that you get in B, put it in B times 4. Area that you get in C, put it in C, and depth of excavation A, and you get the volume of excavation. So that's basically pond construction. So I leave the rest to you guys to work it out so that you can understand better. work it out and try it and get your answer. And some other questions that can come out of this might not be the only question that come out of it. Some other question that might come out of it is, after you have gotten the volume of excavation and you are told that so let's assume after calculating the volume of excavation, we got 100 meter cube. We are assuming. I hope you understand that. We are assuming that the volume of excavation is this. Some other question that can come out of it is, okay, if you are using a bulldozer, and a dozer can excavate 10 meter cube per hour. The capacity of a dozer is this. So how many hours would it work? That would be the question. So the rest is now mathematics. If the capacity is this for 1 hour, then how many hours would it take it to do this? Then the rest is just simple mathematics. Cross multiply 100 divided by 10, x equals to, so 10 is going to take it 10 hours to cover this, and it goes on like that. The rest is just simple mathematics. Every other thing that comes after is just like relating formulas to one formulas. And if they also ask, what is the cost of hiring a bulldozer? What will be the cost of hiring a bulldozer if it's if the cost of hiring a bulldozer is 70 hours 70,000 naira per dozer day, per one dozer day, and one dozer day is 8 hours, what will be the cost of hiring it? So the rest is just simple math. It's something you can try it out and get your answer. It's just keep relating. Okay, if this is this, what's this? Just keep relating. It's actually very easy. So that brings us to the end of pond construction 2. And if there's any other question, please just try and reach me out. I'll try as much as I can to reach out to answer your questions personally. And so at this point, I'm rounding up pond construction 2. Thank you. I remain Olasende Faith. Bye.